Good afternoon, my dear students. Today we're going to have another virtual class for Math 6103. This is Calculus 2. Today we're going to have our applications of derivatives 2. So under week 12 po. Today is November 25, 2021. Our schedule is 1:10 to 2:40 p.m. So these are your applications of derivatives 2. At the end of the session, students will be able to use the first derivative of a function to get some information about the graph of a function. Using the derivatives for curve sketching, one of the important uses of derivatives was an aid in curve sketching. In the previous section, we saw how to use the derivative to determine the absolute minimum and maximum values of a function. However, there's a lot more information about a graph that can be determined from the first derivative of a function. Even though we usually use calculator or computer to draw complicated graph, it is still important to understand the relationship between the derivatives and graphs. So let's suppose that we have a function f of x. We know from our work in the previous chapter that the first derivative will be f prime x or y prime. It is the rate of change of the function. We use this idea to identify where a function was increasing or rising, decreasing or falling or not changing. So for the first derivative, if y prime is positive, the curve is rising. If y prime is negative, the curve is falling. If y prime is 0, possible local maximum or minimum. Okay? So we have now your second derivative. When we say second derivative, we call that one as your higher derivative. If y double prime is positive, the curve is concave upward. If y double prime is negative, the curve is concave downward. If y double prime is 0, possible inflection point where concavity changes. So ito na po siya. If y double prime is 0. So take note of the curve, no? Pag ito siya, it only represents the y or the first derivative. Pag second derivative na po, ito yung magiging graph na po niya. So this is now your definition. Given any x1 and x2 from an interval 1 or I with x1 is less than x2 if the function of x1 is less than the function of x2. Then the function of x is increasing on I. Number 2, given any x1 and x2 from an interval I with x1 is less than x2 if the function of x1 is greater than the function of x2, then the function of x is decreasing on I. Now recall that in the previous chapter, we constantly use the idea that if the derivative of a function was positive at a point, then the function was increasing at that point. And if the derivative was negative at a point, then the function was decreasing at that point. We also use the fact that if the derivative of function was 0 at a point, then the function was not changing at that point. We use these ideas to identify the intervals in which a function is increasing and decreasing. The following fact summarizes up what we are doing in the previous chapter. So this is now the fact. If the first derivative of x is greater than 0 for every x in some interval I, then the function of x is increasing on the interval. if the function of x or f prime of x is greater than 0, less than 0, for every x on some interval I, then the function of x is increasing on the interval. If the first derivative of x is equal to 0, for every x on some interval I, then the function of x is constant on the interval. So we have your example. Determine all intervals where the following function is increasing or decreasing. So from our previous lesson last week, okay, from the applications of derivatives 1, in order for us to look for the critical points, there are 4 steps that we're going to do, no? The first one, first is we're going to find the first derivative of the given function. Second, we're going to factor the first derivative. Okay? Third, we're going to equate their first factor, or their factor, the first derivative into 0. And then last, we're going to solve for their critical points. So reminders for the critical points, these are only domain values, which means these are all x values. So with that, the same procedure that we're going to apply in this problem. So solution, to determine if the function is increasing or decreasing, we will need the first derivative. So by using the power rule, no? 5 times negative x, so we have negative 5x to the fourth. 4 by 5 all over 2 is 20 divided by 2, so we have 10x cubed. 3 times 40 is 120 divided by 3 is 40x squared. Plus 5, derivative of 5 is 0, which is constant. So after getting the first derivative, and then we're going to factor. The first common factor will be negative 5x squared. Okay? And the remaining are x squared minus 2x minus 8. And if we're going to factor this one, we're going to have x minus 4, then multiply by x plus 2. So by this time, you're already done with your step 2, factoring the first derivative. The next thing we're going to do, we're going to equate their factor into 0. Negative 5x squared is equal to 0, x minus 4 is equal to 0, x plus 2 is equal to 0. With that, we can find further critical points. Note that we factor the derivative. We first factor a is negative 1, how to make the rest of factoring a little easier. From the factored form, the derivative, we say that we have 3 critical points. So dito, no, x plus 2 is equal to 0, so we're going to have x negative 2. X minus 4 is equal to 0, so we have x is equal to 4. Negative 5x squared is equal to 0, so we have x is equal to 0. So ito na siya. So we'll need this in a bit, no? We now need to determine where the derivative is positive and where it is negative. Since the derivative is a polynomial and it is continuous. And so we know that only way for it to change the sign is to first go through 0. In other words, the only place that the derivative may change signs is at the critical points of the function. We now get another use for the critical points, so we'll build a number line graph that critical points and pick test points from each region to see if the derivative is positive or negative in each region. So with that, here's the number line and the test points for the derivative. Okay? So we have now the 3 critical points. X is negative 2, x is equal to 0, x is equal to 4. So make sure to test your points in the derivative. One of the more common mistakes here is to test the points in the function instead. Recall that we know that the derivative will be the same sign in its region. The only place the derivative can change sign is at the critical points. At we mark the only critical points on the number line. So ito yung mga critical points pa natin from that equation. Okay? So dito, if x equal to 0, 4, and negative 2. So magkakaroon tayo ng test po dito. Kaya tawag po dito, test points, no? So if we're going to have a test points from 0 to negative 2, if the function of x is equal to negative 1, then the answer is 25. Okay, dito, up to 4, if the function of x is equal to 1, the answer is 45. Okay, but if the function is 5, the answer is negative 875. The function is negative 3, the answer is negative 315. Ibig sabihin ito, within this range, we have a positive value. Magmula negative 2 hanggang positive 4. Pero beyond positive 4, our answer is already negative 865. So dito, beyond negative 2 or less than negative 2, the answer is negative 315. Okay? So with that, we can say that for the increased part, x is greater than negative 2, magmula dito hanggang dito, but less than 0. Nag-increase siya. And also, another part, dito, x is greater than 0, but less than 4. So within this region, nagkaroon po tayo ng increase. Yung decrease naman, from x to greater than negative infinity. So magmula dito, beyond your negative 2, and less than negative 2. Okay? So, that is decrease. Dito naman, if x is greater than 4 and positive infinity, and so on. We already have a decreased values. So, this is now our results, no? So, dito ay nagkakaroon ng increase, dito ay nagkaroon ng decrease. So, the next thing we're going to do, we're going to sketch the graph. Sketch the graph of the following function. Ito yung kanina. With the function of x equal negative x to the 5 plus 5 to all over x to the 4th plus 40 all over 3x cubed plus 5. This is our solution. Whenever we sketch a graph, it's nice to have a few points on the graph to give us starting place. So we'll start with the function at the 3 critical points. This will give us some starting points. When we go to sketch the graph, these points are, una, if the function of x is equal to negative 2, and if we're going to substitute it here, the value of your y is negative 29.67. If the function of x is equal to 0, and if we're going to substitute it here, the answer is 5. Whereas, if the function of 4 is x is equal to 4, 1423 divided by 3, the answer is 474.33. So by this time, meron na kayong x and y coordinates. Yung x natin, negative 2, 0, and 4. Yung y coordinates natin, we have negative 29.7, 5, and 47.33. Once these points are graphed, we go to the increasing and decreasing information and start sketching. For reference purposes, here's the increasing and decreasing information. If x is greater than negative 2 but less than 0, and x is greater than 0 but less than 4. Yung decrease naman from x is greater than negative infinity to less than negative 2, and x is greater than 4 and less than positive infinity. Okay? So, note that we are only after a sketch of a graph. As noted, before we started this example, we won't be able to accurately predict the curvature of the graph at this point. So, di accurate, no? Okay. However, even without this information, we will still be able to get a basic idea of what the graph should look like. To get this sketch, we start at the very left of the graph and knowing that the graph must be decreasing and will continue to decrease when get when we get to x is equal to -2. At this point, the function will continue to increase until it gets x is equal to 4. However, note that during the increasing phase, it does not need to go through the point at x is equal to 0. And at this point, we also know that the derivative is 0 here. And so the graph goes through to x is equal to 0 horizontally. So steady po siya, no? Walang galawan. Finally, once we hit x is equal to 4, the graph starts and continues to decrease. Also, note that just like at x is equal to 0, the graph will need to be horizontal when it goes through the other two critical points as well. There's the graph the function. We of course use a graphical program to generate this graph. However, outside of some potential curvature issues, if you follow the increasing decreasing formation and had all the critical points plotted first, you should have something similar to this. So ito na yung graph po natin. Okay? So if x is equal to -2, our y is -29.67. Ito na po siya. If x is equal to 0, y is also 0. If x is equal to 4, our y is 474.33. So alam po natin na magmula less than -2, we have a decreasing. Pero pagkasapit ng -2 up to 0, nagkakaroon tayo ng increase. Okay? From our graph dito, no? Ito siya, no? Magmula dito, pababa po siya. Okay? Dito, positive na siya. Magra-rise po siya hanggang maging 0. Hanggang sa 4, mag-increase pa rin siya. Pero pagdating doon, bababa na po siya. Okay? So, with that, if we're going to look on our figure, if x is equal to -2, our y is -29.67. If x is equal to 0, y is equal to 0. If x is equal to 4, our y is 474.33. So, if we're going to plot from this portion to that part, we have now decreasing. Magmula dito sa -2 at doon sa 0 at doon sa 4 na critical points po natin, we have increasing. Kaya pag titignan po natin, nandito po siya. Ito yung curve po niya. Although it's not perfect, pero meron tayong bases. Makatapos ng -4 po siya, then pusta na po siyang bababa. Decreasing na po siya. So let's use the graph, the sketch from this example to give us very nice test for classifying critical points as relative maximum. So this is your relative maximum and relative minimum or neither minimum or maximum. So this is your relative minimum. Yung nandito. This is your relative maximum. Okay? So, maganda po yung graph po natin, no? Based on our calculated values, and we use the graph and it was been introduced na maganda po yung graphic po natin. Next, we have the first derivative test. Suppose that x is equal to constant is a critical point of f of x, then if the function of x, for the first prime, x is greater than 0 to the left of x, which is constant, and the first derivative of x less than 0 to the right of x is equal to constant, then x is equal to constant is a relative maximum. Pero pagbaliktad naman po siya, if the first derivative of f, which is less than 0 to the left of x, and f prime of x greater than 0 to the right of x is equal to constant, then x is equal to c is a relative minimum. But if the first derivative of x, f prime, is the same sign on both sides of x is equal to c, then x is neither a relative maximum nor relative minimum. It is important to note here that the first derivative test will only classify critical points as relative extrema and not as absolute extrema. As we recall from the finding absolute extrema section, absolute extrema are the largest and smallest function values and may not even exist or be critical points if they do exist. The first derivative test is exactly that, a test using the first derivative. It doesn't ever use the value of the function, and so no conclusions can be drawn from the test about the relative size of the function and the critical points, which will be needed to identify absolute extrema, and can't even begin to address the fact that the absolute extrema may not occur at critical points. So example here, find and classify all the critical points of the following function given the intervals where the function is increasing and decreasing. If g of t is equal to t, the cube root of t squared minus 4. And if we're going to look on our equation, we have here the combinations of a product rule. Okay? So, multiplications po tayo, no? This one represents our u, this one represents our v. So, if we're going to get the first derivative of u times v, we have u dv plus v du. So, our u is equal to t, our v is the cube root of t squared minus 4. So, the same process, first, find the first derivative. Second, factor the first derivative. 3, equate the factors into 0. 4, find the critical points. Solution, we'll need the derivative so we can get our hands on the critical points. As well, that will do some simplification on the derivative to help us find the critical points. So, ito na yung first derivative po natin, no? First derivative of t is equal to t squared minus 4 raised to 1/3. Ito siya, no? T squared minus 4 raised to 1/3. Okay? Yung t, derivative ng t, b du, derivative ng t is 1. dt is 1. So, cancel na po siya. So, raised to 1/3. Okay? Ito siya, no? Yung cube root, that is 1/3. Plus, derivative nito, ng t squared, okay? 1/3 tapos t squared minus 4 raised to 1/3 po siya. So, we have 2/3 t squared multiplied by t squared minus 4 raised to negative 2/3. Supposed to be, this is 1/3. Kasi exponent niya is cube root, no? So, 1/3. Kaso ito, derivative ng t squared is 2t. So, 2t. Times 1, kaya naging 2t squared na po siya. Tapos, yung 1/3 minus 1, naging negative 2/3. So, we have t squared minus 4 is to 1/3 plus 2t squared divided by 3 multiplied by t squared minus 4 raised to 2/3. So, simplify it further, multiply the whole equation by 3, t squared minus 4, ito yung magiging equation po natin. 3t squared plus 2t squared, we have 5t squared. 3 by 4, we have negative 12. And after that, we're going to factor these two. 5t squared minus 12 is equal to 0. 3 times quantity t squared minus 4 raised to 2/3 is equal to 0. So it looks like we'll have 4 critical points here. They are t is equal to plus or minus 2. Pag sinimplify ito, no? Tapos yung 5t squared minus 12, so t squared is equal to 12 all over 5. T will be the square root of 12 all over 5. And that is plus or minus 1.549. Finding interval of increasing and decreasing will also give the classification of the critical points. So let's get those first. Here's a number line with the number of critical points, graph, and test points. So ito yung mga critical points pa natin, 4. Plus or minus 2, negative 2, positive 2. The other is plus 1.549. Ito siya, 1.549. The other is negative 1.49 siya. Then, magkakaroon tayo ng test. So, within this area, if g prime is equal to negative 1.7, the answer is 0.76. Okay? Dito naman, if g prime is 1.7, positive po siya, the answer is also 0.76. Beyond that critical point, if g prime is equal to 3, our answer is 3.76. If our g prime is equal to negative 3, is equal to 3.76. So if we're going to look on the value, they are all positive, no? Okay? So it looks like we got the following interval for increasing and decreasing. So increase po siya if x is greater than negative infinity but less than negative 2. Or x is greater than negative 2 but less than square root of negative 12 all over 5. Or x is greater than square root of 12 all over 5 but less than 2. Or x is equal to greater than 2 but less than positive infinity. Yung decreased area po niya, x is from the less than negative square root of 12 all over 5 but less than positive square root of 12 all over 5. From this, it looks like that t is equal to negative 2 and t is equal to 2 are neither relative minimum or relative maximum. Since the function is increasing on both sides of them, on the other hand, at t is equal to negative square root of 12 all over 5 is a relative maximum. And t is equal to square root of 12 all over 5 is a relative minimum. Okay? So this is our illustration. For completeness sake, here's the graph of the function. If x is equal to negative 2, y is equal to 0. If x is equal to negative 1.49, ry is 1.812. If x is equal to 0, y is equal to 0. If x is equal to negative, positive 1.549, ry is negative 1.812. If x is equal to 2, y is equal to 0. Kaya magmula dito hanggang dito, increasing po tayo. Pero pag dito, pag tingnan dito, we have decreasing hanggang dito. From negative 1.549 to positive 1.549. Kasi pag titingnan po natin dito, 0 na siya, no? Okay, yun po. Kaya nag-bit siya sa 0, pero pagdating dito, nag-i-increase na. Okay? And then we have your d, positive infinity, and then we have your d, negative infinity. So that is now our graph. For completeness sake, here's the graph of our function. And it is accurate po siya based on the data that we have in this solution. Okay? Next. Okay, we have your D. Second derivative test. Okay? Suppose that x is equal to constant